Good morning, ladies and gentlemen. My name is Mr. Royes, and I will be your video sub today. I'm actually in the building. I'm just up in Melissa Feynman's World Religions class, first period. So I also have a video student with me today.
What's up,
my son,
Stephen?
Stephen is here. He's a video student, and I guess that makes me your video father for today. And this is my video daughter. So we've got the whole gang here on Saturday. So it's time for calculus. Okay, let's go. For starters today, I'd like to talk about one of the problems that was probably on the homework, at least it was last year. A problem that students had a lot of questions on was page 430, number 33. And on page 430, number 33, I'm just going to hit the lights here so it's a little easier for you to see. In class, there was a problem on the homework that was y equals, and we're going to make this -2 sine of 2 pi x. Now, as you were doing that on the homework, it's best to think of that as a child of a particular parent. So, video student, go ahead and jot down the green parent function y equals sine x. And on Friday, we learned that this parent function, y equals sine x, has 5 key points: x parent, x, y parent, and the x parent values are 0, pi over 2, pi, 3 pi over 2, and 2 pi. The y parent values, remember sine goes I mid max, d mid min. I mid max, d mid min. And so we started in I mid, or 0. We go 0, 1, 0, -1, 0, 1, 0, -1. Those are the key points on the graph of the parent function. And this blue child function is a linear transformation of that parent function. So if I rewrite this as y divided by -2 equals sine of 2 pi x, then I now have an opportunity to watch 2 movies in reverse in order to figure out how to transform these parent values into child values. So let's set up the x child, y child. And so tell me, Stephen, what would you do, so you see the blue child equation, what would you do to the y parent values to get y child values?
I would multiply them all by -2.
That's right. Multiply by -2 is correct. Well done. So that's 0, -2, 0. Multiply that by -2 to get +2 and 0. Now, notice that this 2 pi is right next to the x, and therefore what should we do to all of the x parents to turn them into x children?
Divide them all by 2 pi.
Divide them all by 2 pi is correct. Now, interestingly, the period, there's actually, instead of going through the tedious steps of dividing all 5 of these numbers by 2 pi, we can take a shortcut. Check this out. The period of the parent function that we learned on Friday is 2 pi. Oh, what a coincidence. So that means that we can divide the entire period by 2 pi. 2 pi divided by 2 pi is 1. So when you're sketching the graph, instead of going out from 0 to 2 pi, we now know the period of this child function is simply 1. And so now we can get those 5 golf balls by taking 1, cutting it in half to get 1/2, cutting it in half again to get 1/4, and multiplying 1/4 by 3 to get 3/4. So in fact, whatever the period is for a child sine function or a child cosine function, you just take the period and divide it by whatever the coefficient of x is here, because watching the movie backwards, that would be divide by that number. We're going to take the whole period and divide it by that number. So now we have the 5 golf balls, just like we did on Friday. I'm going to put them in blue, in 8 point. So we've got 5 humongous golf balls. And the values that Stephen gave me here tell me the heights of those golf balls. Those would be 0, -2. I better mark this on my axis. Here's -1, there's -2, +1, +2, so we've got 0, -2, 0, +2, and 0. So, using appropriate concavity, the graph of this function is going to go, instead of I mid max, D mid min, it's going to start here and it's going to go to a minimum first, and then to a maximum and back down. That's one period. Notice the period is not 2 pi, the period is 1. So that's a problem that students in the past have had a lot of trouble with on assignment 6.1. So since we're not doing our standard student homework presentations today, hopefully this will be helpful to you. Now, the hot dog problem that we do on Tuesday at the beginning of class is going to look like this. Here's a practice hot dog problem for you. It's from the 48 quick sketches. So without a calculator, let's do this practice hot dog problem. Sketch the graph of y equals cosine x over the interval 0 to 2 pi. And if you get stuck, just ask yourself, how would you place the 5 golf balls? Notice I take the period, which is 2 pi, cut it in half again, multiply by 3, and think of the unit circle. Think of cosine on the unit circle as the angle sweeps from 0 to 2 pi radians. So go ahead and try it. Sketch the graph of cosine x from 0 to 2 pi. Stephen, you can help me out here. We are going to place these 5 golf balls on the graph. And since green is my favorite color, we're just going to go in green here. And I've had some sort of malfunction. Houston, we have a problem. It's a foreshadowing of today. You actually get a video clip within video sub. We're going to watch a video clip of a modern math meta-narrative moment. It's going to be a clip from the movie Apollo 13, where that famous phrase, Houston, we have a problem, first came into our vernacular. Now, in some ways, when I promised you at the beginning of the year that we would watch on average 1 video clip for a modern math meta-narrative moment every 6 weeks, I'm kind of surprised you let me get away with not showing you a video clip during the second 6 weeks. I'm surprised there wasn't an uprising, a rebellion. So today we're going to watch our second video clip. You're going to get an opportunity to watch a video clip from Apollo 13 and check to see if there's any connections between the video clip and the modern math meta-narrative, which states that mathematicians get out of bed every day because they care about protecting and rescuing people from suffering by creating meaningful models of unfamiliar real-world situations. We use these models to uncover truth, make predictions, and make decisions that optimize scarce resources. So, that's coming up, so don't go away. So here we go. I think this is working again. Stephen, I need your help in placing these golf balls. Where should I put... no, I'm just going to move this up a little bit higher. This is the y-axis. And what's the cosine of 0, Stephen?
1.
Yeah, there we go. 1 is correct, so this first golf ball goes up to 1. How about pi over 2?
0.
Pi?
-1.
-1 is correct. Cosine of 3 pi over 2? 2 pi?
1.
You got it. So, instead of just going like an absolute value, down and up, watch the concavity on that, and we're just gonna go max, d mid, min, I mid, max. So when I say go, I'd like all of you to say out loud and in unison, max, d mid, min, I mid, max, d mid, min. And for those of you who are in 4th grade and you have no idea what I'm talking about,
Seriously.
it's I mid and D mid, in case you're wondering what I'm saying. Okay, so when I say go, I want you to say max, D mid, min, etc. Ready? Go. Max, D mid, min, I mid. That's pretty close. It's pretty close. Here, you know, let's try it again. It'll go max, D mid, min, I mid, max.
Max, D mid, min, I mid, max.
Yes, yes, that was actually really good. Okay, ready? Go. Max, D mid,
min, I mid, max.
Ah, yeah, that's the mnemonic device for the cosine parent function. And so anyway, I'll be hot dogging you on those, you'll have hot dog problems on, I didn't see that coming, Elia, so thank you, video daughter. That was pretty funny. All right, so now it's time, we have 4 examples today. So, anyone knows what time we started? Steve, do you notice what time we started? It was like 20 after?
Yeah.
So,
Yeah.
Sure it was. Okay, I just need to make sure we don't go over time. So here we go. Our first problem for today, number 1. All right. Number 1 is y equals, we're going to sketch the graph here, y equals 5 cosine of x over 4. And semicolon, the interval on which I want you to sketch this graph is negative 2 pi. That's parentheses. Negative 2 pi, comma 4 pi, square bracket. And so here's the plan. Let's just, first of all, figure out what the period is and the amplitude. This is a child of a cosine parent. And so if you think of this as a cosine parent where we divide both sides by 5, you can tell what the amplitude and period are. The amplitude essentially tells you what the vertical stretch is going to be. What are we going to multiply the y's by? And the period is going to essentially respond to a horizontal stretch or shrink. So in this case, since the period is ordinarily 2 pi, the amplitude is going to be stretched by 5, so the amplitude is going to be 5. It's going to be oscillating between plus or minus 5 instead of plus or minus 1. And the period, instead of being 2 pi, is going to be stretched by a factor of 4. So it's going to be 2 pi times 4. So as we set up the graph here, let's set up the 5 key points and then see how far we have to extend it in order to honor the floor and the ceiling that are given on the domain. So this is x and y. The period is 8 pi. So let's go all the way out to 8 pi, and we're going to get this routine going. I don't know if you noticed this happening on Friday, but we're always going to get ready to plot 5 points. And those 5 points, the 5th golf ball will be at the period, the 3rd golf ball will be at half of the period, the 2nd golf ball will be at, as in, 1, 2, 3, 4, 5. This is the 5th golf ball. So the very last golf ball is the period. The 1st golf ball, of course, is at 0. But anyway, this golf ball in the middle is always half of the period. This 2nd golf ball here is going to be half of the period. And then we take this and multiply it by 3 to get that one. So the routine is going to be this. Starting with the period, we cut it in half again, and multiply by 3. So when I say go, I want all of you to say out loud and in unison, cut it in half again, multiply by 3. Ready? Go. Cut it in half again, multiply by 3. And that helps us set up the 5 golf balls. We've got 0, 2 pi, 4 pi, 6 pi, and 8 pi. Okay, and since the amplitude is 5, that means that instead of oscillating between plus or minus 1, we're going to be oscillating between plus or minus 5. There's essentially a vertical stretch by a factor of 5. So now, it's cosine. Stephen, does cosine start at a max, an I mid, a D mid, or a min?
Max.
That's right, cosine starts at a max. So we're just going to start up here, we're going to go, let's just sketch the whole thing. We're not yet paying attention to this boundary. We're just sketching one period. So maybe we can do it kind of lightly, but we're going to go max. In fact, I kind of like to set up these golf balls first, these targets. We're going to go max, D mid, min, I mid, max. Now, had the direction said sketch the graph on the interval 0 to 8 pi, we would be done. But it didn't say that. It said sketch it from negative 2 pi to 4 pi. Well, notice each quarter period, and we're going to refer to quarter periods a lot. In fact, whenever you're looking at a trig function, yes, you need its period, but you also want to put its quarter period in your back pocket. So, since our period is 8 pi, a fourth of 8 is 2 pi. We want a 2 pi in our back pocket. Why would we ever put a quarter period in our back pocket? It's because we need it sometimes to extend the graph. If I want to go the next one over here, it's going to be a quarter period back. So I'm going to go back to negative 2 pi. So let's extend the pattern. And we've got, is it open or closed circle?
Open.
Open circle. So now I'm going to switch to 8 point, so it's a nice thick 8-point red. So the actual answer has an open circle at negative 2 pi, and then I'm going to keep going until I hit 4 pi and do a closed circle. That's the actual answer. The directions were, just keep in mind, the directions were to sketch the graph of y equals 5 cosine of x over 4 on the interval negative 2 pi to 4 pi. And there we have our answer. That's the first of 4 examples in this lesson. Do you have any questions on this example video, student Stephen?
Nope.
Got it? Okay, so let's move on. Number 2. Problem 2 is we're sketching negative 1/4 sine of x over 6. Here it is. Write it down for you. We've got a child of the sine x parent. This is a child of the sine x parent. It's negative 1/4 sine of x over 6. And we're going to sketch this over the interval negative pi to 5 pi. So, let's talk this through here. What do you anticipate the amplitude is going to be? The parent graph has an amplitude of 1. And amplitudes are sensitive to vertical stretching. So when I ask you, what is the amplitude? That's a code language for asking you, what's the vertical stretch factor going to be? But then for amplitude, amplitude is always a non-negative number, so it would be the absolute value. The absolute value of that. But what do you think the amplitude is going to be on this? Stephen, do you see it?
4.
Yeah, if you bring the 4 over the other side, that means we're going to be, I mean, if you multiply both sides by 4, actually, yeah. I see why you said 4. Because when you bring 4 to the other side, it's like times 4. But really, let's write out the other version of this. The alternate version of this, from which you can read the amplitude in the period, is when the number that affects y is on the same side as y. So if I write this as negative 4y equals sine of x over 6, you see that the vertical stretch factor is really what?
1/4.
Yeah, the amplitude is 1/4. The vertical stretch factor is negative 1/4. So that means we're going to take our sine parent, reflect it over the x-axis, and compress it by a factor of 4. But so the amplitude is, by definition, the absolute value of the vertical stretch factor, which in this case is 1/4. And now, so we need the amplitude to find out what stretch would be. Now the period. We know the period is ordinarily 2 pi, but we see that the period is sensitive to horizontal compression and stretches. So Stephen, tell me what you think the period is going to be.
12 pi.
Yeah, it's ordinarily 2 pi multiplied by 6 to get 12 pi. So now let's set up our axes. And let's do the whole thing from 0 to 12 pi. And so since our child period is 12 pi, Stephen, I'm going to give you the routine of cut in half again, multiplied by 3, and you tell me what the outcomes are. Cut it in half.
6 pi.
6 pi is correct. Cut it in half again.
3 pi.
Multiply that by 3.
9 pi.
9 pi is correct. Okay, so now we've got to remember we're a child of sine, so sine starts at an I mid, but because it's a negative 1/4 in front, it's going to really start out with a D mid. So the chant that's going to guide us through this is going to be D mid, min, I mid, max, and it's tiny. It's got an amplitude of only 1/4. So we're going to be oscillating between positive 1/4 and negative 1/4, starting in a D mid. I sometimes like to draw those golf balls first. D mid, min, I mid, max, D mid, and we've got our graph, at least from 0 to 12 pi. But the directions probably didn't say 0 to 12 pi. Oh, sure enough. The direction said go from negative pi to 5 pi. So we're going to have to take the portion of this. So I'm going to go a quarter period. This is a quarter period. So I'm going to go a quarter period back. Negative 3 pi up at the top. Okay, so that's negative 3 pi. We need to go from negative pi. I can kind of see which golf ball that is. So I'm going to switch to green for the final answer. We'll go 4-point green. It's not green? Okay, 4-point green. Here's negative pi. 1, 2, 3, 4, 5. And here's 5 pi. What was it? It was square bracket on both. So I've got negative pi square bracket and go up to 5 pi square bracket. I'm going to call this, in fact, if you want to get the endpoints, the left endpoint is point A, the right endpoint is point B, and the coordinates of point A are negative pi, comma, and then the coordinates of point B are 5 pi, comma. To find the y coordinates of points A and B, you would simply plug negative pi in here. In fact, let's try that. Stephen, help me out here. What's the sine of negative pi over 6? You can ignore the negative 1/4 for now. What's the sine of negative pi over 6? Circle.
Negative 1/2.
Negative 1/2 is correct. So we got negative 1/2 times negative 1/4 is positive 1/8, which does seem to agree with our graph. That looks like it could in fact be a golf ball. That's 1/8 of a unit above ground. How about point B? Well, to find out what the y coordinate of point B is, I'm going to plug 5 pi in for x here, and oh, check it out. 5 pi over 6. What's the sine of 5 pi over 6?
It's 1/2.
1/2 is correct, and so 1/2 times negative 1/4 is negative 1/8, and that does agree with our graph. We've now completed example number 2 in our lesson, which was to sketch the graph of this function from negative pi to 5 pi. Do you have any questions on that?
If we know that it's going to be less than 6 pi, can we just leave out the whole sine graph right there?
Yeah, I mean, this is, you can think of this as a training wheel approach. And again, I don't know how well the sound is working here. So in case you didn't hear the question, in my first period class, the question is, do you have to draw all this extra stuff if you know it's not going to go beyond there? And no, you don't. I mean, if you know it's going to be, if you're going along, you go D mid, min, I mid, that's all I need, so I'm not going to do the rest. That's fine. You can just stop right there. And, all right. So next, let's go to number 3. We got 3 equations. Yeah, we're doing okay time-wise. Again, there's 4 examples in this lesson. Now let's go to the real world of the time. Suppose we're in Ocean City, New Jersey.
Yay!
And that's my video daughter's favorite vacation spot?
Except for Hawaii.
Except for Hawaii. And how many times have you been to Hawaii, little girl?
0.
Zero, but you've been there in your mind several times. And my daughter has an American Girl doll who lives in Hawaii, supposedly, I guess. What's her name? Kanani?
Yeah.
Yeah, okay. So, imagine we're in Ocean City, New Jersey, and, oops, and we have tides going in and out. Problem 3 is the tides problem. And we're going to take a graph and go back to an equation. So far in the examples we've been doing, I've been giving you an equation and asking you to generate the graph. Now we're going the other way around. I'm giving you the graph, and you're going to produce for me the equation. So we're going to let x represent time measured in hours, hours after midnight, and y is going to represent the depth of the water in feet, feet above or below an arbitrary marker. And suppose that at midnight, x equals 0 corresponds to midnight. At midnight, the ocean level is 7 feet below an arbitrary marker. And it also happens to be low tide. And the tides, fortunately, we have a moon, and the moon causes this tidal effect of, the gravity of the moon pulling the water in, making it high tide, and then, because of the pulling, sometimes you get a low tide. And if it wasn't for the moon, we'd all be dead. Because, does anyone know what the moon does? Steve, do you know what the moon does to keep us alive?
Keeps us in orbit?
No, it actually, do you know, Elia, what the moon, why we would die if we didn't have the moon?
Because,
What it does is when it pulls the water, when the tide's going in and out, that
you should
actually.
have said about the waves then.
Oh yeah, okay. Well, do you know what those waves cause?
Because there would be no waves otherwise.
Yeah, and if there weren't that tidal action, there wouldn't be any oxygen getting into the ocean water to feed the algae, which are at the foundation of
Why
the
do we
food
need
supply.
algae?
Well, we don't eat algae, at least not
Yeah,
on
what does it do
weekends.
for us anyways?
What?
Then why would we die without?
Because we eat the things that eat the algae. And so there's like fish, and then the whales, they end up eating the fish, and not that we eat whales either. But without the moon, there'd be no tides. Without the tides, there'd be no oxygen in the ocean. Without oxygen in the ocean, there'd be no algae surviving. And everything, the whole food chain, rests on algae in the ocean. So.
Well, that's not the only thing we can eat. Seafood.
Well, that's, yeah. Well, we'll talk more about that later. You got some good questions. There's some good challenges. So, alrighty. Have to. So we've got 12 hours, because 12 hours later it's low tide again. And let's say that high tide is 7 feet above the arbitrary marker. And we want to come up with the equation of this thing. Well, Stephen, you're looking at this graph, and the truth is a sinusoid is a sinusoid. Both sine and cosine have a sinusoidal graph. So we could use either sine or cosine to model this. But whether we use sine or cosine, we'll decide that later. What does it appear the amplitude, or the absolute value of the vertical stretch factor is?
7.
Yeah, it looks like the amplitude is 7. And it looks like the period is ordinarily 2 pi, but we did something to this 2 pi to stretch it out to a factor of 12. So the period is clearly now 12. But the question is, how are we gonna set up the movie to watch the movie backwards so that we get a 12? Well, that's what we're gonna work on. So here we go. when we want to sketch the graph of this function, would you be inclined, since it starts at a min, would you be inclined to use sine or cosine to model this? Again, you could go either way, but one of them requires a horizontal shift and the other one does not require a horizontal shift. So would you be inclined to go with sine or cosine?
Sine.
Okay, sine starts at an imid. So we would have to horizontally shift this back if we want to go with sine. Since it starts, if it starts at either a max or a min, then you want to go with cosine. If it starts at an imid or a dmid, then you want to go with sine. So since it starts at a min, we're going to go with cosine. It's going to be -7 cosine of 2 pi has got to be somehow altered. Min times x. Well, I'd like to argue that the period is always going to go under the 2 pi. I think, here, let's see if I can make that work. 2 pi over the period. Will that truly give us a period of 12? Well, we know that if we're just watching the movie backwards here, the parent graph, I'll put the parent graph in green, y equals cosine x. The parent graph has a period of 2 pi. Now what you can do is look at a sequence of problems to see how you can always get the period put under a 2 pi in order to make it work. If the parent function has a period of 2 pi, then what would the period of cosine of 2 pi x be? You know, I'm going to zoom in on this so that people can actually see what I'm writing. It's a little bit tiny. So it's just a sequence of problems to show you how to go from graph to equation and just take the period off of the graph and plug it right into the equation. That's the purpose of this sequence of problems. So if the period of cosine x is 2 pi, then Stephen, what's the period of cosine 2 pi x?
1.
Yeah, it's 2 pi divided by 2 pi equals 1. So now I've got a special function that always has a period of 1. And so then you can take this function that has a period of 1 and stretch it to any period you want. So if you want to go from 1 to 12, what would you do to the 2 pi x to stretch it out to a factor of 12?
Divided by 12.
Divided by 12. So that's why in general, whatever the period is that you observe in the graph, just put it under 2 pi. And that will be the period right there. That's the easiest way to model period in this. So, all right, so now my video daughter has become video camera girl. How's it looking on the camera?
Fine.
Yeah? Did you move it around at all, or?
Yeah, but I made sure everything was still on the camera.
Okay, is your video brother still in the camera?
His face is.
All right, okay.
But it's not when he's leaning back like that.
All right. Okay. So we have video daughter, video camera girl, and video director. That's good. That's good. I like that. Now, so the problem was, what's the equation of the tides that gives us the tides at any given time? The answer that we came up with was y equals -7 cosine of 2 pi over 12x. All right, now for our last problem. This is one for you to do on your own. And, well, no, maybe there's 2 more. I wasn't counting correctly. Okay, Stephen and students in class and video daughter, if you want to do this one. Okay, I'm just kidding, you don't have to do this one.
You said if you wanted to do this one.
Right. So here it is. I'm going to give you a graph, and I'd like you to write the equation of the graph. And we'll go in blue. I think that shows it pretty well. We've got d-mid, min, I-mid, max, d-mid. This is a sinusoidal function that oscillates between -6 and 6, and the period is 31. Go ahead and write the equation of that graph. Go ahead and tell me what you think it is.
Well, the amplitude is going to be 6.
Okay.
So And it's gonna be, let's see, that's gonna be a sine graph. And it goes 2 pi over 31x.
2 pi over 31x. Now, there is one thing left off in here. So far we have y equals 6 sine of 2 pi over 31x. There's one adjustment that needs to be made. In fact, I'll tell you, if you were to sketch what you have right now, it would look like this.
So you just need to multiply something by -1,
Yeah, where should I put the -1 in?
right in front of the 6.
Right in front of the 6. That's right. So the final answer is y equals -6 sine of 2 pi over 31x. Now, now this really is the last problem. The last problem is to look at y equals sine of 1/2 times x plus pi over 4.
Hey, Dad.
And,
Can't really see that question in the camera.
okay,
It's too light.
it's too light.
Can barely see it.
All right, here, let me make it a darker color. I'll just make it blue. Okay, and you know what, I'll even make it bigger like that. Is that better?
If you look in the right angle. Mm-hmm.
Okay, all right. Thank you. Thank you, Elia. My students, my first grade students, appreciate that. And, set myself up. Now, all right, so here's what we do. This is, the only thing that's different between this one and the other ones we've done is that we just have a horizontal shift of pi over 4 units left. Pi over 4 units left. So what we're going to do is we're going to ignore that, plot 5 golf balls, and then we're going to take all 5 golf balls and shift them pi over 4 units left. We're almost done squeaking, then I'll go get you a drink, okay? So, here we go. Let's ignore that. Amplitude is what, Stephen?
Amplitude is 1.
1. And the period is ordinarily 2 pi. In fact, what you can do, you can actually, since that the period is always the number under 2 pi, you can, if you want, you can force a 2 pi in here. I'm going to multiply by 1 in the form 2 pi over 2 pi. So now I see that there is something under the 2 pi. It's 4 pi. So that's one way to get a period of 4 pi. But another way is to say, well, look, it says 1 divided by 2. I mean, come on, dividing by 2, that would multiply the period by 2. So that would be the other way to get 4 pi. So now let's go ahead and do this. Let's take the period of 4 pi, cut it in half again, multiply by 3. And that gives us 5 purple golf balls starting I mid, max, D mid, min, I mid. I'm going to label these A, B, C, D, and E. And those are the unshifted golf balls. In fact, what I'm going to do is just set up the unshifted ordered pairs A, B, C, D, and E right here. And my, 0, pi, 2 pi, 3 pi. Can you see the purple okay on the camera?
Yeah.
Okay, and then since the amplitude is 1, this just goes I mid max, D mid, min, I mid. So now the final answer is the same thing as this, except all 5 golf balls have to be shifted pi over 4 units left. So the final answer in green is going to look like this. Purple shifted left gives us green. In fact, I could call these points A prime, B prime, C prime, D prime, and E prime. A prime, D prime, oops, B prime, C prime, D prime, E prime. And then I'm going to note that nothing happens to the y coordinates. They're still 0, 1, 0, -1, 0. The only thing that's different is I have to subtract pi over 4 from each of these x coordinates. So it's going to be negative pi over 4, comma 0. That's this point here. What's pi minus pi over 4? I guess that'd be 3 pi over 4. 2 pi is 8 pi over 4 minus pi over 4 is 7 pi over 4. 3 pi is 12 pi over 4. Minus pi over 4 is 11 pi over 4. And 4 pi is 16 pi over 4. Minus pi over 4 is 15 pi over 4. So, there you have it. That's a systematic, reliable way to find the coordinates of a horizontally shifted sine or cosine graph. So assignment 6.2 is due tomorrow. 6.2 is due Tuesday. It's time to watch a video clip from Apollo 13. This is the modern math meta-narrative moment. Alrighty, so hey everyone, I was checking the time, how much time it took to tape this, and I realized that we're not going to have a chance to see the Apollo 13 clip today. So Tuesday, we'll start out class Tuesday looking at the modern math meta-narrative moment. Right. I'm so glad that the camera is still there. Okay, thank you. So we'll see you on Tuesday. Assignment 6.2 is due on Tuesday. Bye now. I should say short.
Can we like